In this video, we're going to look at the process we would go through to actually construct a frequency distribution. So, to construct a frequency distribution, there's a variety of steps, a number of steps. The first step is we should determine how many classes we want to have. Right? So we select the number of classes. This number of classes, it is typically somewhere between 5 and 20. That's going to be dependent on the number of values in your data set. If your number of values is small, you're using a frequency distribution to try to summarize that data or to condense that data, make it easier to read, and so you would choose a smaller number of classes. If I have 20 data values and I choose 20 different values, that's not, or 20 different classes, that doesn't really make the data any easier to consume. I might as well have just given all the raw data. Right? So here this helps it to be easier to consume. If we have 100 or 500 different data values, then we're going to use quite a few more classes, unless all those classes happen to be, all those values happen to be clustered really closely together, in which case maybe we wouldn't. But the data would help to dictate that. After we have identified the number of classes, the next thing that we will do is we will calculate the class width. And that class width, the way we will typically do this is we will take our absolute largest value, the maximum value, minus the minimum value in our data set, so the values we actually see, and then we are going to divide that by the number of classes. Now here I used an approximate sign, all right, so it's approximately this amount. I use an approximation sign there because this number that we get is not the number that we will necessarily use. Typically we round up to the next nice number. And what do we mean by nice number? Well, that depends on our data set. So if our data set only has integer values, we would round up to the next integer value probably. If our data consists of values that go to the nearest tenth, we would round up to the nearest tenth. However, in both of those cases, we tend to like things that are multiples of 5. And so if we happen to be close to a multiple of 5, maybe we wouldn't round up to 4, but maybe we would round up to 5 because that's a nice, cleaner number. And so we might do that. There we have a lot of flexibility with what we would do, but we round up to a nice value. After we've found this class width, the next thing that we are going to do is we're going to choose the value for the first lower class limit. So this might either be the smallest value, or it might be a nice value that is smaller than the smallest value. And so that is, so we have our class width that we calculated in step 2. We find our first lower class limit by either choosing it to be the smallest data value that we observed, or something that is a little bit smaller than our smallest data value, but it's just a nicer value. Next up, we want to determine the other lower class limits. And the way we do this is we repeatedly add the class width. And we put these in a vertical column. We determine the upper class limits based on the lower class limits. And we put those in a vertical column. Usually we put those in the same column with a dash between the lower class limit and the associated upper class limit. And then finally, we determine the frequency for each of those classes. All right, so let's look at an example. I know that's a lot to go through, but let's take a look at an example where we're going to go through this process. All right, so the first, we're going to construct a frequency distribution for the number of calories in beef hot dogs, and we are going to use a hot dog data set. This data set is shown here. It is a data set that comes from Consumer Reports from several years ago, and it analyzed 3 different types of hot dogs, beef, poultry, and meat. We're going to look just at the beef hot dogs, and for those beef hot dogs, we see that there were 20 different cases of beef hot dogs, and here are those 20 different cases. We want to look at the number of calories. And so our smallest value that we observe is right here, 111. And the absolute largest value that we observe is somewhere right here, which is 190. Those will be important when we get to step 2. The first thing we want to do is we want to determine how many classes are we going to use. So there are 20 cases of beef hot dogs here. Let's choose something that's small, 5, 6, or 7. Let's go ahead and choose 7. You might say, why did you choose 7? I would have chosen 6, or I would have chosen 5. And I would say, that's fine. It's up to you. You can choose that. Those values are okay to choose as well. Unless you are doing some kind of problem where it's specific, we're told the number of classes, we can choose the number of classes. I chose 7 because I created a table down here that already has 7 spaces. Next, we find the class width. Remember, we take our maximum value, which is 190, minus our minimum value, which is 111, and divide that by 7. And if we do that, we get 11 point some business. Right? I don't know what that value was specifically. 11.2857. All of our values are whole number values. They are positive integer values. And so I'm going to round this up to 12. Going up to 15, that's kind of a little bit of a stretch. That's going a little bit further. So I'm going to just round that to 12. Next, we choose our first lower class limit. For that first lower class limit, we either choose the smallest value, which was 111, or a nice value below that. I'm going to choose 110. There's not a real great reason for choosing 110 other than it's nice, but my later lower class limits, because my class width is 12, they're not going to look real nice. And so starting with 111 would have made plenty of sense as well. All right, so now we've gone through our first 3 steps where we have identified the number of classes 7, we've determined a class width of 12, and our first lower class limit, we're going to start with 110. We find the remaining lower class limits by repeatedly adding the class width. So we are going to add 12. So 110 plus 12 is 122. Add 12 again, and we get 134. Add 12 again, and we get 146. Add 12 again, and we get 158. Add 12 again, and we get 170. Add 12 again, and we get 192. All right, so that's how we found all of our lower class limits. To find our upper class limits, we determine the upper class limits based on the lower class limits. And so what that means is the next class starts at 122. So this class had to end just before that. It's going to end at 121. This one ends at 134, so this last one, 133, was the last value that we could have seen. And then 145, and then 157, and then 169, and 1 90, oh, this should have been 182 here. And so 181, and then 193. And you might say, how did you know it was 193? If I would have continued this process to find the next lower class limit, if I added 12 to this, I would have gotten 194, and so 193 would have been that last upper class limit. Also, that class width, it shows up over and over again. So notice that 121 plus 12 gives us 133. 133 plus 12 plus our class width gives us 145. Add 12 again and we get 157. Add 12 again, we get 169. Add 12 again and add 12 again, and we keep getting our new class widths. All right, so now we've gone through steps 1, 2, 3, 4, and this was step 5, coming up with those upper class limits. So the last thing that we have is we need to find our frequencies. So I'm going to jump back and forth between our data set. So we need to count the number of values that are between 110 and 121. And I went ahead and highlighted these so it will be quicker for us to pick those out. But the only value there is 111. So there is one value between 110 and 121. Next, we're looking for values between 122 and 133. And so when we look for values between 122 and 133, we have, starting at the bottom, 1, 2 values. So we have 2 values there. Next up, we're looking for values between 134 and 145. So 134 and 145. Here we are. 1 value, 2 values there. Next, we are looking for values between 146 and 157. So 146 and 157, we have 1, 2, 3, 4, 5, 6. So we have 6 values there. Next, we're going to look for values between 158 and 169. (158 to 169, including 169). So there's 1 value. One value there. 170 through 181. We have 1, 2, 3, 3 values. And finally, from 182 to 193, we have 1, 2, 3, 4 values. So we have 4 values there. Now, some of you may have noticed that I missed a value. Let's pretend like I didn't miss a value for a moment. Here's how I can check that. I'm going to go ahead and add up these frequencies. So when I add up all of these frequencies right here, 1 plus 2 plus 2 plus 6 is 11. 12, 13, 14, 15, 16, 17, 18, 19. Right now, those only add up to 19. but the total number of data values we had in our data set was 20. So I missed something. Let's go back and look. We missed this 139 right there. So we need to add one more into the number, whichever number had the 139 value. So 139, that occurs in this, and so I'm going to replace that 2 with a 3. And now we get all 20. We do have all 20 of them represented. That's the process that we would go through to create a frequency distribution. We will talk to you guys later.